This screencast is about polyatomic ions, and if you look at the word, you can probably break it down into two parts. Okay, you'll see poly and you'll see atomic. So hopefully you remember from math, you might have heard of polygons. Poly means many, and of course atomic means atoms. So these are groups of atoms that work together as a unit. So these groups you're going to find on the back of your pink sheet. So if you don't already have it out, please take out your pink periodic table and flip it over to the back side. Okay, anything that is more than one atom, so more than one capital letter. So you'll see NH4 plus, that is your only cation. That is a polyatomic ion, but you'll notice pretty much everything down here, these are all polyatomic ions or groups of ions that work together as one unit. You do not need to memorize these. You will have this every time you take a test or quiz where you'll require this information. Again, you don't really need to know how to do this, but just so you understand where these come from. If you remember doing our electron dot diagrams for bonding, you'll see that nitrogen really only needs 3 hydrogens. Okay, so in order to fit a 4th one in, it basically has to kick this electron out. So to fit that 4th hydrogen in, it's got to get rid of 1 electron to have room for its. And that 1 electron that it's giving away is where that plus charge comes from. And that's similar for the negative ions as well, so I'll do an example with that for you. We look at OH minus, which is called hydroxide. We know that oxygen has its 6 valence electrons, or 6 outermost electrons. Hydrogen with 1 would fit in here. So in order to stabilize this, it needs 1 extra electron. That electron is coming from something else, and that is where this idea of the negative charge comes from, because it's picking up an extra electron that neither of these two atoms, either the oxygen or the hydrogen, has. So that's why it works together as a unit. So all of this is going to work as a group. So what we need to remember when we put these into compounds is that it is a group and we have to treat it as a unit. So just like any other ionic compound that we write, we need to get the same number of positives as we do negative charges. So we can still do our crisscross and reduce. So all of those same rules apply. We just need to keep this group together. So when I crisscross these guys, I'm going to end up with Ca and then OH, but I want to keep that together as a unit and put a 2 with it. Now, problem with this one is this doesn't look wrong. I have trouble drawing it wrong. This doesn't look wrong, but it is incorrect because I need to keep this together as a unit. If I choose 2 other ions, I have magnesium with phosphate. So again, I'm going to crisscross my charges. I'm going to get Mg with a 3 and then PO4 with a 2. Now, you'll notice PO4 42 would look really wrong, so this one you also have to have parentheses with it. So the rule is if there's more than one of a polyatomic ion, it must be in parentheses. So again, if there's more than one of a polyatomic ion, it must be enclosed in parentheses. If there's just one, there's no parentheses needed. So if we do something like magnesium and carbonate. Okay, this is what a lot of seashells have in them, these types of formulas. So again, when we have crisscross and reduce, these are going to cancel. So if I bring my 2 down here and my 2 down here, I can divide both of these by 2 and they just disappear. So my formula would be MgCO3, no parentheses. Okay, you'll be getting a copy of this worksheet from your teacher, and I'm going to ask you to do just a couple columns here. I'm not going to do them all. The one thing I do need to warn you about, folks, is don't use parentheses all the time. So a lot of people, when they get to this one, and I'm going to hopefully blow this up a little bit, is they're going to want to put parentheses on everything. So when we come back to this, you don't want to do MgCl2 with parentheses. You never use it if it's just one. So chlorine is not a polyatomic ion, so no parentheses ever for that, no matter how many of them there are. So I'm going to ask you to do these three columns, the OH column, the SO4 column, and the PO4 column. Once you get those done, please show that to your teacher. Again, I will try to be working around to see where you are with this to help you if you're getting stuck.